So hello everyone, we're glad to see you here today on our IT Talk meeting with our expert Nikolay Litvinchuk. We will talk today about AWS Bedrock as an implementation option of the AI assistant. Compare lexical and semantic search together with some alternatives to AWS Bedrock. You could leave all your questions here in chat and our expert will answer them during the meeting. And also, you will be able to find the record of this meeting here on YouTube by the same link. So, our today's speaker is Nikolay Litvinchuk. He's a technical architect at DataArt. So, Nikolay, welcome. The floor is yours.
Hello, everyone. Nice to see you all here today. I'm a technical architect in DataArt, and today I will tell you a short story about implementing AI assistants using AWS Bedrock, and will answer why we chose Bedrock, some alternatives, and maybe some more interesting information. So first and first, what was the problem? Why we wanted to use Bedrock? It started from our product owner, and at some moment of time, he said that our chatbot is bad and no one liked to use it. And basically, what was the reason why he said it? So this is an example of a chatbot, but not ours. The main idea that as far as we have a growing user base, the number of applications to our application is growing with the time, and it means that more and more people have questions which should be answered before they apply or during the application, and that is why they more frequently asking questions from the chatbot. And actually, this chatbot is not too helpful because we have increased load with more and more calls to our operation team. And basically, what our chatbot doing, it is legacy implementation, and why it is bad for our particular case is just because another team is owning this solution, and if you want to change something, it is taken really long time. It could be a couple of sprints or even sometime months when we can request something and have some changes implemented there. So most of the time, it is like a simple search based on the question of the customers by some special words, and then it is generate a number of the answers or questions which customer probably asked and meant. So as far as we all knew that this is the current solution is really bad, like it is nice to do something with it, but unfortunately we have our like timelines. That is why we wanted to implement something on our own, but we have like really limited time to do it. So for like non-functional requirements, it was limited time to implement proof of concept and probably solution, and then this solution should require minimum support from our side. So this is like an input for us, and as a next step, I just wanted to compare briefly two different approach. So basically, this is like a lexical search and semantic search. So basically, lexical search, it's like a simple search, and by the keywords or by some synonyms or other things. And basically, it is how nowadays work in most of the search tools. For example, Elasticsearch or Solr, which are all based on the Lucene indexes, and basically based on how you index the data, you can achieve either good results or not really good based on the type of the indexing you have chosen. But anyway, it is not so it is more focused on searching exact matches. So this is an idea. And as far as like people nowadays searching might have searched by some different queries, which probably won't be even in your results. We need to change our direction on how we're looking into the search. So here is coming the semantic search. So semantic search focuses on understanding meaning and how this particular query from the customer is lying in terms of the logical comparison to the data which we already have. And if you look on the image on the right, you could see that all these semantic searches nowadays are based on the vectors. And basically what's going on here, so when customers search for some query, somehow magically, and it is basically magic happen on the side of the AI nowadays. This query is converted to the vector. It can be a huge amount of vector parameters. It could be like hundreds based on the AI model you chose. And then this vector is, based on this vector, we search in some similarities, for example, by cosine similarity or other similarity searches which are implemented. We search it in the huge vector space. So this is the main idea by the semantic search. And why it is good? It is good because it is much easier to search by unstructured data. So sometimes it could be even images, not just the text. So this is the main idea. And for our purpose, it was a good thing to move from the lexical search to the semantic search. And one of the options to implement this kind of search was Ollama, and this is open source tool which allows you to run LLMs or large language models locally. And the good thing that it can be Dockerized. And if you take a look on the picture, you could see that this picture contains two processes. Basically, it is processing and retrieving. And for the processing, we need the embedding model. And this embedding model is used to process data from, for example, from S3 bucket, or it depends on your needs. And I'll show you further which option Bedrock supports. You can get all this data converted using embedding models to the vector representation, and then this vector representation will be stored in the vector database. So what is good in this approach for our particular case is that we have a full control of AI model, and sometimes it could be a huge benefit, depends on the business, because not all businesses are keen on to use or delegate all responsibility to and to store the data on the side of the some storages which is hosted in the cloud. So this is full control over AI model, and it could be Dockerized, so it can be simpler uploaded to the web or spun into your local hosting. And as for cons, maintenance cost will be much higher because you have to have person who will work on it and support it probably data. So data processing will be on your side as well, and then you have to also monitor it and also provide on your own vector storage or vector database of any kind. So, and as you can see, almost all this pros and cons aren't fit into our purpose to have something really fast and to have less support or maintainability for it. So another option for us was to use some either Azure or Google or AWS cloud services. And as far as our company was already using AWS, so it was like easy pickup for us. It's AWS Bedrock, so it's fully managed service which choose high performance, which gives us higher performance. Also, it is compliant and it's developing really, really fast right now. So as for pros, it is fully managed service. So as you can see, we don't need to Dockerize anything. So all the features will come out of the box, and we just need to prepare call to AWS Bedrock accordingly. So performance is also good. It is compliant, and as for cons, it is limited control and also vendor lock, because for some companies it is like not a good thing, because probably it will be really, really difficult to move out from AWS Bedrock to Azure OpenAI, for example, because actually, as far as this is a service, except of the requests, you're not like really owning anything. So it will be hard to move out of this solution. Yeah. So let's move further. So how to configure server side for the AWS Bedrock. So first of all, you should choose data source, and this is like really growing part of it. So you can use either Amazon S3 bucket. You can put or use how many buckets you want. Then you can use web crawler, and I use it for our purposes, for our company, and it was really good because you can specify only top folder or top URL location, and it will crawl everything which is interconnected to the stop page. So it is really, really interesting and good thing. So you can use your custom location and also Confluence, because for the knowledge bases for a lot of companies, Confluence is like one of the biggest source of truth. You probably won't find a lot of data in some PDF files or other documents, and most of information will be in Confluence page. And also it could be frequently re-indexed. So it is a good thing if you want to keep your data up to date. So next thing is to choose vector store, and it will be a location where we will put our data. So we can either choose our vector store, or we can choose, for example, something which is provided by the AWS, and it is OpenSearch serverless. It is really, really good and fast implementation of the vector store, and it is really fast. But the only concern is the price. It was one of the biggest consumer of our credits. So this is something to think about, and probably some other companies can choose even use Amazon Aurora PostgreSQL with vector store plugins. So, and the next thing which should be specified is model, and this is embedded models. And for your particular case, you should think and check which models are available in your region, because not all models available in all regions, and probably you by some policy your company cannot use, for example, some US regions, but you require, for example, London or Paris or any other location. So it is something to keep in mind from the beginning, that not all models are available in all regions. And when you'll create all this configuration, the last thing which will left for you is just to hit sync button, and all the data which you specified in as a data source will be processed. And one more interesting note here is that you can't perform all the section using your root user. So just keep in mind that you need to create additional users with Bedrock permissions. Yeah, I think it's all here. So next thing was for us to implement client side, and as for client side, there are multiple options here. So if you're using Python, you can use like bare AWS SDK, and for Python it will be Boto 3. For Java, actually, we use for our proof of concept Java SDK, and it is like really simple to add. So you just have to add one dependency, create a client, and generate a call. Yeah, it will be a lot of boilerplate code for Java, but anyway, it's one time created, and it's not too difficult to code it. But unfortunately for Java, it wasn't too many example even in AWS. So and from my point of view, Python libraries are developed more rapidly nowadays. So if you have options, for example, to implement your client using not Java, but using Python, it is, in my point of view, more preferable way. And if you're still using Java or other languages, there is Spring AI, and the most interesting is LangChain and LangGraph. But for our particular case, we don't need it because we wanted to have our solution as simple as possible, and that is why we haven't implemented really like chatbot with a history. So it is like more like retrieval data with some minor augmentation. So this is it here. And next it is like example which I'll show you a bit later, and it will be shown in the Python because I like it more for the proof of concept. And as you can see, the response for it is consists from several parts. So one part it is like data, and sorry, it's like probably unreadable in here and right now, but it will just show us that each particular data which was retrieved, it has connection to some, it will be either S3 bucket or probably URL. So if you work with it as a knowledge base, you will always have a proof. So for your operation team, for example, or for a customer, you can always say that this is an answer, and say that if you want to double check it, to provide this either S3 proof link to some file, or to picture, or probably to some site or conference if it is available for your particular case. So next thing, it is pricing. So, for example, for our proof of concept, it was like for 1 month. It majority of the cost was the cost of the open search, and it cost us like a couple of $100. And if you can see, for example, I use Mistral 7B, and for one, you could see that the pricing for 1,000 tokens, it will be like really small. So basically, the part of the AI usage here, it is not too big. So if you have, for example, 100,000 or probably 1 million tokens, it will cost you a couple of dollars. So it is like really cheap. So for some people and companies, it will be nice to use maybe maybe alternatives to the vector store which provided by default by the Amazon, but solution is really cheap if you want to make it as simple as possible. And as for next steps for us will be if this solution will pass through all the procurement process, which is currently in progress. We will definitely use guardrails, probably use alternative vector stores, just to look what will be the price. Maybe adjust some prompts. We'll add chat capabilities and might use agents to perform some additional actions. So, and actually all this function is really easy implemented in the AWS Bedrock. And as we go to example, I want to show you a simple example how it look like. So for our particular case, we use and retrieve and generate. So basically, it is something like RAG implementation. But if you don't want to change response and you have like really fine-grained data store with like questions and answers, which do not require any changes or augmentation, you can use just retrieve, and in this case you probably even omit AI part to generate something. So basically you will just need to convert input from the customer to vector implementation or representation. So I specified knowledge base ID, which was generated by the Bedrock. Then I also have my credential stored locally, and if it is some account, you can add it to the property files or to the secrets. Then I specify model which I want to use. Then how many results I want to see, some prompting. Then to use temperature or top P parameter, token numbers, and this is part related to the querying and orchestration configuration. This is part related to the generation. So here temperature and top P parameter will be even more interesting. And I used one I chose to use simple book, Little Prince, and I put it to the S3 bucket. It was processed by the AWS Bedrock, and now we can, for example, query a couple of questions to the Bedrock and specify, for example, here temperature is really low. What it means is that based on the input of our customers, we don't want to have anything which is not probably present in the documentation, and to keep response as close to the results as possible, or to the source as possible. And if we, for example, put like 1 it means that we will give to AI like a huge wildcard to probably rephrase something and to return information, and it might even vary from the query to query. So we can query the same question, but result will be different anytime. So we can, and we can run it right now. Yeah, so it's pretty fast. And for example, if we have chosen to use Ollama, we definitely had to have beefy environments for Ollama itself to perform augmentation. And we also required really beefy environment to the vector store. So this probably won't be a really great thing from the amount of money which customer will spend on support and on spending this environment, because most of the time probably it will wait for queries, and probably like it is not a good solution to have it working all the time, and it is better to have option just to request information when it is needed. So, yep, this is one response, and as far as it is like 0101, and it should be as close to the source as possible. It won't generate anything extra out of information it has in a book. And the good thing that there is information and link on the source when it get this information. So this is the interesting part, and it could be always shared with the customer. And also, if you want to have multiple responses, if you specify various number of results, it can be more than two, or like you can present to the customer one, two, or three, or even more results which you want to see. And the second is different response. Okay, it's almost the same. It's interesting. Yeah, so it can be sometimes. Yeah, as you can see, this time it's changed. So if we specify 0101, as you can see, it's almost always the same response. If we give him if we give to AI more wider options to generate response, you can see that there are several planets, and number is not specified, but sometimes it can even return exact numbers. But yeah, it is like how AI work, and you should probably look on the acceptance criteria and the needs of your project, what should be achieved. But the main goals from our side were achieved. It was to create proof of concept, and for our proof of concept, it take roughly 2.5 weeks from the idea to have a proof of concept which is working and which were presented to higher staff, and they were pretty we had really good responses from their side, so that is why we looking forward to reach all approval and procurements and to move it as fast as possible to production. I think it's all from my side, and we can move to questions. Thanks everyone for participating. Okay. I'll read it. What were the key decision factor for choosing AWS Bedrock over alternatives like Ollama self-hosting models? Yeah, so for our particular case, so it was performance. It is first of all, and as far as you're using not really big environment, there's response could you can wait for response probably sometimes even for minutes, and it is unacceptable for users. And if you have like really big environment, it will cost like could cost really a lot, and most of the time it will just wait for you to, or for the customer to write some queries. So this was the main thing for us, but yeah, it can vary from the customer to customer. Maybe someone will want to have complete control, but for AWS Bedrock, you don't need to worry about updating. For example, Ollama itself do not need to worry about to change models, because if I come back here, if you want to use another model to get data, so you can move to the configuration file, this Mistral, and change version. And if you have Ollama, you should fetch this model, and yeah, it will take much more time, and it will require some people who will support it and monitor 24/7. Okay, so as for factors which should count, so it actually depends on the data and on the nature of your company. So basically, there are most of the top tier models are almost the same, but for example, some of the models can be really moderated and do not pass a lot of answers. So probably if you ask some political questions or something like this, it won't work for you. So you should look on this part, because as I work and try some couple of different models for my particular case, I haven't witnessed any like significant difference, because you provide some information and it just simply working with it. So it depends on the generation part. If the generation part or augmented part of your query can be some or can have some tricks, or probably you're working with some coding, so you probably need the models, exact models, which more likely will be close to the coding and generate better coding results. So what industries or types of businesses can benefit the most from the implementing? What kind of industries? It is hard to say because it will vary from your particular case. So, for example, if it is some financial or, for example, healthcare, uh, you probably should think twice before you replace uh, like real people with AI assistants. So you should be extremely sure of the data which you're generating, and it should be monitored. So here it is hard to say, but for example, uh, mm, if you have some data, unstructured data, which you want to return results based on it, and for example, you have like newcomers which come to your project, or uh, probably not just newcomers, but so it will help to onboard people. For example, if the growing based on the information is grow like every day, it is much more easier to work here with AI assistant, which will understand context instead of the simple lexical search. So I hope I answered this question. How does the cost of running an AI system on AWS scale with usage, and how do you manage cost optimization? Yeah, so at this moment, it is like a proof of concept, and as I can see from the biggest part of the cost at this particular moment, it lays with vector storage. So you can even scale this vector storage up. So you can add more cores there. So it will work faster. And I mean, to pay for it like a couple of $100 per month, probably it's not a big of a deal for a big company. So scaling shouldn't be issue here. And as far as it is service, it is like scaling. It is the nature of AWS Bedrock, so it will work really, really fine and with any amount of requests. So it is a good part of it, which probably will be hard to achieve with self-hosted variant as Ollama. What was the biggest challenge for it? And which is the best and cheapest way to build your first AI agent? Which models to choose? Yeah. So, what was the biggest challenge while implementing AWS Bedrock? So basically, from my perspective, the biggest challenge was probably to have first request working in Java, because client part was AWS SDK part was really poorly described, and as far as we are Java team, it were more preferable to use Java there. So it made some time for me to implement it. And basically what I've done, I had Python implementation. I just converted it to Java because it wasn't any an complete document how to generate it, but all classes were described to great, but it wasn't any example on how to instantiate or call it first time. So yeah, and which is the best and cheapest way to build our first agent, which models to choose. As for models, I probably answer it above. It depends on the industry which you're working, and if we come back to the price, and it is not cost too much. Okay. Yeah, so it doesn't cost too much. So the price for the models usage is really cheap. So, and as for building your first AI agent, AWS Bedrock has support for AI agents. So you can look on it. It should be really simple to implement it with any type of any type of even language you use. You can simply attach your AI agent call with AWS Lambda function, and it will be triggered by your model, and this Lambda function will instantiate your agent. How big was your S3, and what was the average time of implemented? Yeah, okay, so it wasn't really big. So for I mean, it's just one PDF file. As for our knowledge base, which I used, we actually used location not in S3 buckets, but in the web. So it was crawled, and it also wasn't too huge, but based on the information which I saw in the internet, if the most difficult part will be your S3, not S3, but vector storage. If I came back to this part, so the most interesting thing is to put all the data which you have to the vector store, and vector stores are optimized based on the type of the vector stores to work with even 100 gigabytes, and this similarity search will perform really great, and that is why this vector stores exist. And when the search itself happening, for example, it will be picked up top 10 or top 20 answers, and based on these top 20 answers, it will be instantiated. If you go here, it will be instantiated or triggered text model, and based on the knowledge which this text model has, and plus these 10 answers from the vector store, virtually it is really doesn't matter how many information you have in the vector store, because AI model itself will work with a limited amount of relevant responses which were found by the similarity search. And based on the similarity search result, Bedrock, using this text model, in our case it was Mistral, it will generate augmented or probably even retrieved response. So yeah, I think answered here. And yeah, so average time, it's almost the same, should be the same based on the vector store performance. So this Amazon vector store is really, really good. That is why cost a lot. And if you want like really beefy model, it will cost even more for you. And as for text model, it is like almost the same time. So it is working really fast. And all this Bedrock service was created with scaling in mind, but you should keep this information that probably it could become your vendor log. And as far as Bedrock is working, like really, really too good, I probably do not see like easy way to move out from Bedrock, for example, to Ollama, because the complexity of the implementation could be much, much bigger, and maintainability cost. Yeah, I think answers all questions.
Yes, I believe it was the last question. Thank you, Nikolay. Thank you, everyone who joined us today. We hope this information was useful for you, and see you at our other events. Have a nice day.
Thanks, everyone. Bye.